We're going to look at topic 64, example 5, where we identify transformations from an equation. So everything has kind of been laid out here for us. We just need to write out what the transformations are. And they're asking us what transformations of f of x equals x squared result in the graph of the function g. So in part A, we have g of x is equal to negative 1/3 x, and then that term squared. So we have this 1/3 here, and we have this negative, and those are going to be our two transformations. We just have to determine what those transformations actually are, what they look like, and how we can kind of write them out in words. In the graph, I've put this dotted line here to represent h, and what that's going to do is that's going to represent that 1/3 and whatever transformation that is. And then after we make that change, we would then make the transformation with that negative, and that would give us g. So our end result would be this red function here, g of x. Now, in terms of that 1/3, if we go back up to our concept stretches and compressions, when we have a value inside the parentheses, all right, that k value, that's going to be in terms of a horizontal stretch or compression. So then we need to look at whether it's a stretch or compression, and that's going to be determined whether it's between 0 and 1 or whether it's greater than 1. And for this example, we're looking at 1/3, so that's going to be between 0 and 1. So this tells us that we're going to have a horizontal stretch. Now, one of the ways to see that, and it's not always very clear, is that if I took this point here, this point is getting moved outside to there. And that horizontal stretch, remember, I talked about it kind of being backwards. That multiplied by 1/3 is actually we're going to multiply the numbers by 3. So this 1, 1 becomes 1/3. And well, if you multiply the number 1 by 3, you would get 3. So that's how it's kind of displayed. Whether you pick up on that right away or not is kind of tricky. Some of you may get it, some might not. But the idea is that you should recognize that if the number is inside like that and it's between 0 and 1, then it is going to be a horizontal stretch. So let's write that down. We have I'll write that in green, keep everything color coded like I like to. We have a horizontal stretch by a factor of, since we're using that 1/3, that would be our stretch. So horizontal stretch by a factor of 1/3. And now this negative on the outside, we talked about this here. Hopefully remember that those negatives are going to cause reflections, and we just need to determine whether it is a reflection over the x or the y-axis. Well, in this case, we can pretty clearly see based on our graph that it's going to reflect over the x-axis. It's reflecting from top to bottom. So we would have a reflection over the x-axis. And that's all they're looking for here. They're looking for what are the transformations that were done. So that's it. In part B, we have g of x is equal to x minus 4 squared plus 5. So we have here, let's kind of do the same thing. We're going to look at this minus 4, and we're going to look at this plus 5. So the minus 4 is shown as that green dotted line, all right, that green parabola, what we refer to as h on the graph. And you'll see that this is shifted over 4 places. And I've mentioned it a couple of times, but you do want to remember that if it's inside your grouping symbols, so inside these parentheses, it's going to be backwards. And kind of like that 1/3 in part A was actually multiplying by 3 because we were stretching it. It's kind of the same thing here, right? We're subtracting 4, but that actually means that we have a shift. So we would say we have a shift 4 units right. Although we're subtracting 4, we are going to move the graph to the right. We're going to shift right. And then that plus 5 on the outside is going to be a vertical shift. So that's going to determine whether it goes up or down. That's straightforward, very easy to figure out. It's plus 5. So that's where we took this vertex here and we shifted it up 5 places, or 5 units. So we would say that we have a shift 5 units up. And that's it. That one, obviously, it looks much easier. Stretches and compressions tend to be a little bit more work. You have to be a little bit more careful with them. But shifts left, right, up, and down tend to be very, very direct and straightforward.